Alright, Chapter 7, Review number 12. We're trying to find the area of the region enclosed by these lines and curves. So I'm going to make a little sketch. Y equals 2 sine x is just sine x, except it has an amplitude of 2. So it'll look like that. And then sine of 2x, well, that 2, if you remember, the period is 2 pi over b. That's what the period is. So in this case, it's 2 pi over 2. So it has a period of pi. So it takes pi units in order to complete the curve. It has an amplitude of 1 out front, so it's going to look like that. And it does say from 0 to pi, so we just have this much to work with. So if we didn't know that they intersected at pi, we could set those equal to each other. Just a little trig equation review. 2 sine x equals sine of 2x. Sine 2x, that's a double angle for sine, so that's the same as 2 sine x cosine x. And you can move everything to one side. I'll move it to the right side too. Factor out a 2 sine x, left with cosine x minus 1. Set them equal to 0. Sine is 0, or yeah, equal to 0 at 0, pi, and so on. Set that equal to 0. When is cosine equal to 1? That would be at 0 and 2 pi, etc. Okay, so they intersect at 0 and pi, which we have here is 0 and pi. Alright, so finding that area, you just have to find the integral of the top minus the bottom, so it's 2 sine x is the one above, minus sine of 2x from 0 to pi, and evaluate that. Find the antiderivative. Antiderivative of 2 sine x is negative 2 cosine x. Antiderivative of negative sine 2x would be, it's the cosine of 2x. But 1/2 cosine 2x from 0 to pi. So cosine pi is negative 1, so negative 2 times negative 1 would be 2, plus cosine 2 pi is 1, times 1/2 is 1/2, so 2 plus 1/2, minus the cosine of 0 is 1, times negative 2 is negative 2, plus cosine of 0 is 1, times 1/2 is just 1/2. Alright, so I have 5 halves. This is negative 3 halves, so plus 3 halves gives me 8 halves, or 4 for the area.